We're going to look at how to create a basic contour toolpath. In creating this toolpath, the geometry that we're going to utilize is going to be the wireframe, which is in the color green around the top edge of our model. But before we get started doing that, I want to make sure that our screens are synchronized on a couple of things. First of all, for the machine type, I've selected the default machine definition that Mastercam comes loaded with. The other thing is that I'm going to load in a toolbar with my 2D toolpaths in it. To do that, I'm going to go to Settings, Toolbar States, and I'm going to select 2D Toolpaths and click Load. You should see these toolbars load in on your screen if you don't have them there already. I'll click the green check mark for OK. The next thing that I would like to do is go over to Properties and click on the plus and expand it out. You'll find 4 categories: Files, Tool Settings, Stock Setup, and Safety Zone. The one that I would like to focus on is Stock Setup. Click on it and it will open this window. What we're going to do is create a virtual definition of our stock boundary. I'm going to move my cursor over here and make sure that rectangular is toggled. And what we're out to accomplish is to create basically a rectangular shoebox that fits around our model. Now you'll notice that our X, Y, and Z values have a 0 value in each of them. Stock origin, I don't want you to worry about this at all. This does not have anything to do with where your program 0 is. This is only placement of your virtual stock boundaries. If you leave this alone and utilize bounding box, it will automatically position your stock where it needs to be done. To save us any type of confusion, don't input any values in this. Don't move this little indicator around. You can click on it and drag it. Let's leave it in the middle and select bounding box. Now what this does is this allows the system to look at all the geometry that's on your screen and build this virtual shoebox around it. Click. It automatically puts in values. You can have it display. It'll be wireframe, or you can have it as a solid. I'll accept it and watch what appears on your screen. You'll see this virtual definition of our stock in phantom lines surrounding your part. Go to top view and you'll see that it encapsulates our entire model. Now if you wish, you can go back to your stock setup and we can add, go plus 0.1 in X and Y, plus 0.1. Enter. Now let's look at our stock representation. You can see that it's now 100 thousandths oversize, giving us a 50 thousandths gap in each direction. Okay, so we've created our stock boundary. What this is for is in Verify. Verify looks to stock setup for the definition of this representation of material that it will show you. Without that, it utilizes your toolpath, which may not be a true representation of what you're after. Next, we're going to create our toolpath. Now, there are several ways of getting to your toolpaths. One is to click right here for Contour Toolpath. Another way would be to right-click in the white, Mill Toolpaths, Contour. A third way is to go up along our top menu, select Toolpaths, and then drop down to Contour Toolpath right over here. I'm going to select my Contour Toolpath icon, which brings me to my chaining dialog window. Now, as I said before, the geometry that I would like to be using for this is going to be the green wireframe around the upper edge of our part. So there's no confusion. I'm going to go to my Levels Manager. I'll come down here, click on Level, and level number 1 I'm going to uncheck the visibility column. In essence, I'm turning my solid off. I'll accept it. And all you should see is our stock boundary and our wireframe. Okay, I'm going to chain, and I'm going to pick at the lower end of this first straight line. The reason I'm down at the lower end is because I want my chain to shoot the long direction so that I'm climb milling around my part. So how you're picking your chain can determine the direction of your cut. If I am on this side of center, the high side of center, my tool is going to go this direction. If I'm on the low side of center of this first entity, it's going to go this direction. So I'm going to pick right here. Now we can reverse this later on, but it's much more efficient to pick your geometry the first time than having to go back and edit it later. So I'm going to click right here, and you'll see that there is an arrow pointing in that direction, which is what I want. I want to be on the outside. I want to be climb milling. I'll accept this, and it brings us to our contour parameter pages. Now the only thing I'm going to look at here at the moment is selecting a tool from the library, and we're going to add a comment. I'm going to click the Select Library Tool button. I've got my filter turned on so that I'm only looking at flat end mills. And I'm looking for a 1/2 inch end mill. I'll accept it, and it loads it into my window. Next thing I'm going to do is go into comments. I'm just going to say first toolpath. And we'll go on to our contour parameters page. We'll click here. The two things I'm going to look at right now are our top of stock, which is 0, and the depth of the final cut. Now there's two ways of inputting this value. One is to type it in, and the other is to go to the graphics screen and select something that is representing the depth of our cut. Well, I'll click on the depth button, which brings us to our graphics screen. And the problem is that there's nothing that represents the bottom of our cut. Nothing locks in on our bounding box because this is virtual representation. It's not real geometry, so nothing's going to lock in on it. You see how we're getting indicators on our cursor that it's locking in on some kind of an entity, whereas out here, nothing is happening. So the only z-depth that entities are existing is at 0 at the moment. Let's go back to our Levels Manager and turn our solid back on. Say OK. Now what I'm going to do is unshade our model. So Alt-S unshades it. And the thing to be careful of is the fact that there are fillets on these corners. So I'm going to zoom in right into this area right here, F1, and draw a window around it and zoom in. Now you'll see that there are fillets. So if I lock in on any of these solid edges, I have to be really careful what I'm going to choose because up here is not going to be at my full depth. This very well could be. I know for sure that where the fillet of this hole comes out is blending in with the bottom face of our part, and that's going to be my final depth. I'll click on that. And sure enough, it puts in a -1/2 of an inch. So we have our top of stock, our final depth. Want to go up here to compensation type. In computer, it's going to plot the center line of the toolpath. It will not post our cutter comp offset codes. In control, it will post our cutter comp offset codes, and it will plot the edge of our part. Where calculates the center line of the toolpath, but also posts out the cutter comp codes. This is the one that we are going to be using because at that point, at your machine control, you are only going to input a value that is the difference between what you are saying your tool diameter is and what it really is. So for instance, if you have a reground end mill, you can compensate for the amount that the tool has been ground down to as opposed to its virtual definition in here. Our compensation direction is going to be to the left. Tip compensation will be to the very tip of our tool. You have another option here for center, so this will be potentially for using a ball end mill. Rolling cutters around corners. This keeps the tool in contact with the part around sharp corners. Infinite look ahead. Keeps the tool from over-traveling on inside corners. XY stock to leave and Z stock to leave. This is so that you can leave additional material. For instance, if I wanted to rough this using a 1/2-inch end mill and then come back and finish it with, say, a 3/8 end mill, I could leave 10 or 15 thousandths here, then come back with a different tool and clean it up. So I could use this for a roughing tool path without having to create any other geometry that represents a larger profile. I'll come over here. I could do multi-passes. I can do depth cuts. Breakthrough amount. Okay, this is a depth that will be added to this. So if we want our tool to go a little bit beyond the 1/2 inch just to make sure it kind of breaks through, I can click this, breakthrough, and let's just add 50 thou. Lead in, lead out. I'm going to have this checked, enter at a midpoint. And these values I want at 100% as well as these values. In another video, we're going to focus more closely on the parameters that you have within lead and lead out. So right now, just set these basic parameters, accept it. And click OK. We'll fit to screen. And notice the toolpath that is created. We're leading in, going around our part, and then leading out. We'll select our toolpath and we'll backplot it. I'm going to go to my top view and we'll start our toolpath. It comes on and we're doing a climb cut around the profile of our part. Notice our Z depth down here. We're at a Z depth of minus 550. Remember, initially our depth was 500 thousandths, plus we added breakthrough amount of 50 thousandths. And we sweep off. This is how to create our basic contour toolpath.
We're going to take a look at the basics of contour toolpath creation in this video. For the purposes of this video, we're going to be machining the outside of this part, which is represented by the wireframe that runs along the top and outside here in green. Before we get started, though, let's make sure that we all have the same tools to work with as we move along in this project. First of all, you notice here, if I expand this menu here, it says that I have a generic mill. If I look under Files here, we can see that this is the Mastercam default machine definition and default control. Let's close out of here. If you don't see this on your screen, or if you've opened up in the design mode, make sure you go up here to Machine Type, Mill, and Default, and select that, and that'll put that in your Operations Manager. Secondly, we want to make sure that we have access to our contour toolpath icon, which you can see right up here. If you don't see that on your screen, go to Settings, and then Toolbar States, and select 2D Toolpaths, and then Load. And what that will do here is supply that entire 2D Toolpath toolbar here on the left side of your screen. The next thing you want to do prior to creating a toolpath is to define your stock setup. The same 4 items you see here on the Properties menu are available when you click up here on the tabs in the Machine Groups property page. So here under Stock Setup, we have a lot of choices here, and what we're going to use is a rectangular shaped stock. Now, we don't want to pay any attention to this stock origin right now in order not to complicate matters. Suffice it to say that Mastercam will automatically set the settings for you in order to be able to create your stock. So what we want to do then is look at the options that we have down here at the bottom of the page for selecting our stock boundaries. You notice that we are using a solid in here, so if we selected all solids, it would create the exact shape of a rectangle along with the correct center point in order to cover that entire part. But as you can see, there's nothing in here in the Z height. The reason for that is because we are not in the 3D mode. So let's close out of here and select the 3D mode and then go back into Stock Setup. Now when we do the same thing, select all solids, then you notice it adds the thickness of the part as well. Let's unselect that, and we can see that by using all entities, it does exactly the same thing. Now, under bounding box, it's slightly different. It will do what we had just previously done. It actually shows you the bounding box, and we have the options of actually creating geometry in the form of lines and arcs. We can create points on the endpoints. We can create a center point. If we hit Alt-S and unshade our part, we can see that there's a center point right in the middle of the stock. And we can also create a solid, which will actually create a solid in a solid manager that you could use as stock. Right now we're just going to concentrate on stock, and we'll close out of here. And we see that the values that we have here. What one might generally do is select a nominal size that's somewhat larger. Let's say in this instance we would put it 4.5 inch stock by 4.5. And a 1/2 inch stock would be the actual thickness, but since we're machining around the entire part, we'd probably want to add some material to hold on to in the vise, so we could put another 1/8 of an inch on there, so say 0.625. And if we have this display button on, we'll be able to see that as we close out of here. So now let's look at this in the top view, and we can see that we have a boundary that goes entirely around the part if we put the screen, and there's extra material to cut off. Let's put this back in isometric view for our machining purposes. Remember, the outside boundary of this stock is not anything that we can select, but is strictly for the purposes of verification so that we can see exactly how we're machining. Now we're actually going to create our contour toolpath. There's 3 ways to get to that. We've already seen the contour icon here off to the side. And another way that we could do it is to right-click on the Operations Manager, go to Mill Toolpath, go down here to Contour, and then a third way would be to take a trip up here to the toolbar, select Toolpath, drop down, and select Contour. So let's select the Contour icon, and when you do that, you're going to be asked to enter in a new NC file name. We're going to select the one that's given to us there, and under the chaining menu, we have a lot of different options here as well. In other videos, we'll take a look in greater detail about what all these different buttons mean and what we can use them for, but we're just going to be using the full chain contour at this time. So in order for it to be less confusing, I'm going to go ahead and turn off the red solid here by going into my Level Manager, selecting Solid, and unchecking it. When I go out of here, now that you can see we just have a 2D wireframe toolpath that represents our part. Okay, so this depressed icon here is for a full chain loop. Now, when we go to select our chain, we want to make sure that we actually select it in the proper location. And by that I mean, if we select here on the lower end of this line, you notice how it chains all the way around the part, and we see the arrow is heading this direction. If I was to go here and to unselect this and then select again on the upper end of that, the arrow would go the opposite direction. But since our cutter is on the left-hand side, we would be climb cutting on the wrong side. That's something that we can change later on. In fact, you can actually flip it here if you like. However, we want to start this on that long chain, so we're going to unselect again, make sure we select on the lower end of the chain. The arrow goes the direction that we want. So this begins our chaining process. So we know we're in the climb milling mode, so let's go ahead and complete this by clicking OK. Now once we do that, you'll notice that we have this dialog box that comes up that's a suite of different 2D toolpaths. Right now we're selecting the contour, and we have a visual representation here, something similar to what we're doing. And up here we see that our chain geometry equals 1 chain, which is what we expect. Now the next choice on our scrolling menu is our actual tool. If we don't see the tool we want here in our tool manager, we simply need to select Library Tool or right-click on our field and select Tool Manager. And we'll be able to see all the tools that are in our various tool libraries. If I go under Filter here and I make sure that I only have selected the flat end mill type and then activate the filter, And I can go in here and select a 1/2 inch end mill, which I will do. And due to our current tool settings, that throws it in there as tool number 1. So the tool I'm going to use is a 1/2 inch flat end mill. So I'll click OK here on the Tool Manager, and I'll go down here to the Cut Parameters page. The first thing we see is the compensation type and the compensation direction. For climb milling, we always want to make sure our cutter is left. On the compensation type, computer means basically that we are machining the cutter path rather than the part path, which is the part path plus the radius of the tool. If we went to control, we'd be machining strictly on the part path with cutter comp, and the radius or diameter would be added right at the machine. If we go to where is the same as the computer, except that we would be adding the G41 or G42 for our cutter comp. Over here, the contour type that we're using is strict 2D. And then we're going to use our tip comp, which is the tip. The other option is center, which you might use if you're using a ball end mill. Roll cutters around corner simply means that the tool stays in contact for a more efficient motion as it goes around corners. And we could leave stock on walls or stock on floors if we were looking at this as a roughing operation. Let's take a look at our lead in, lead out. Now in our lead in, lead out, by default, right now we can see it set to length equaling 100% of the tool diameter for our line entry, and an arc entry that is also 100% of the diameter of the tool. And we have a sweep of 90 degrees. So if I wanted the exit to equal the enter, I would click on this transfer button, and it would move everything on the left side over to the right side. But those values are already the same. By having this one checked, enter at exit at midpoint and close contours, we do have a closed contour, so the line that we selected, the tool would actually arc on and off in the middle of that line that we chose as our start point. So let's go ahead and accept that. Next we have a breakthrough. Now since we're machining on the outside of the part and we're going to end up having to flip it over and machine the backside off, we probably do want to have some sort of a breakthrough, which is a distance beyond the bottom of the part that we would be machining to. So if we can add, say, 20 thousandths to the breakthrough amount, we'll make sure that we actually have gone past the edge of the part in order to be able to clean up the other side. Let's go on down to our linking parameters here. And this is where we actually set the depth of our cut. We can use Mastercam to select the depth of the cut by clicking on the depth button. However, right now we only have a 2D wireframe to work with, which is set at Z0. So selecting on the wireframe will not give us any different depth dimensions. We're still sitting at 0. What we can do is type in the actual amount, what we know to be the thickness of the part, which would be a 1/2 inch in the negative direction. However, another way to do it, if we close out of here and turn on our solid, would be to use Mastercam once again. Let's go back in here to the parameters page, select on the depth button, and if we go down to the bottom of the part, let's zoom in just a little bit. And we can see we want to make sure that we get the actual bottom of the part because there are radiuses on here. So if I select what I know to be the bottom of the part, it gives me a depth of minus a 1/2 inch. Now that we've done that, let's go ahead and close out of here and fit our screen again. In fact, let's go ahead and put it in the top view by right-clicking on our graphics area and clicking top. Let's make sure that we fit our screen here. And now let's go ahead and regenerate and watch it in Backplot. And as we go into Backplot, we'll notice as we move along through here, down at the bottom, we can watch the tool depth as we go along. So let's go ahead and click through here a step at a time. And you notice that it's down to 520 thousandths. And I'll go ahead and click on play, and it's going to machine all the way around the part. And I can speed that up here as I watch it. And then it arcs off the amount that we told it to. So this is the basics of creating a contour toolpath.